Hello class, this lesson we're going to learn about the law of cosines. So once again, here is SOHCAHTOA. Now let's look at the law of cosines. Here we have one version of it. I'd like you to read this equation and describe what the equation is telling you in your own words. So here's one explanation. We have the square of one side of a triangle. That's equal to the sum of the squares of the other two sides minus this quantity. Notice that in this quantity we have cosine, hence the name law of cosines. And if the beginning here looks familiar, that is no coincidence. We get that from Pythagorean theorem. And that's because law of cosines is actually a generalization of Pythagorean theorem. Now, the term generalization means that it can do everything Pythagorean theorem can, but more. So let's see why that is. What happens if we plug in 90 degrees for angle C? So we plug that into our formula, what do we end up getting? Well, what is cosine of 90? We saw in a previous lesson that was 0. If you don't remember that, you can always double check on your calculator, make sure you're in degree mode, that should be 0. So we end up getting what we know from Pythagorean theorem. But now we can use law of cosines for other types of triangles. We don't have to have a right triangle. So let's see where law of cosines comes from. Here we have a triangle and we drop an altitude. I'd like you to rewrite E and H in terms of angle C and angle A. So how can you express E using trigonometry with angle C and side length A? And do the same for H. So to rewrite H, you could say that is A times the sine of angle C. Right? Sine is opposite over hypotenuse, apply the cross product, and that's what you get. Similar idea for E, but we're going to use cosine. Now with triangle ABD, what do we notice? What can we write about the side lengths? Well, if we use Pythagorean theorem, we end up with this equation. And now the goal is to substitute what we have up here for H and E into this equation. So we have the C squared like we wanted, but we want to get rid of this D and H. So how can we rewrite D? How can we rewrite H? Well, H is easy because H is just this quantity. So we plug that in. Now D is this piece, and we know E is A times the cosine of angle C. So to get the B involved, we'd have to say, well, D is equal to B minus E. And E is this amount. So to rewrite D, it's a little bit different, but there's the idea. I'm going to subtract B and A times the cosine of angle C. Now this looks closer to what we wanted, right? We have A, B, and C involved. We want to get rid of the sign somehow. So let's see what happens when we simplify this. So I'd like you to take a moment, try to simplify this by evaluating or multiplying, figure out what this binomial is squared, and figure out what you get on over here with A times the sine of angle C. So when you evaluate this product right here, we get this expression, and you can just square each factor here because it's a product, and we end up with this equation. Now, if we factor out this A squared, we get something nice in here. What can we do with this expression? What's that equal to? Well, we saw in a previous lesson that that is the Pythagorean identity. So this whole expression in blue is equal to 1. So now we got rid of the sign. And all we got to do is rearrange things here, and we have the law of cosines. So notice that the side that we're looking at over here, that corresponds to the angle that we're using inside the cosine. So that's to be true no matter how we write the law of cosines. So what other ways could we arrange this equation? Well, if you wanted to put A squared on the left-hand side, you would write this equation. And what if we want B squared over there? That's what you get. So notice how the letters move around and how the angle has to correspond to this quantity over here. So now let's apply what we've learned. Here we have a triangle. We got those 75-degree angles. And we want to figure out the distance from D to A using the law of cosines. So how can we do that? Well, first of all, what do we notice about this triangle? We know that it is isosceles by the converse of the base angles theorem. Okay, so those are both 75 degrees. It's isosceles. So this is going to be nice because we know B and A are equal. It's going to help us in our problem. So there's our law of cosines. I'd like you to take a moment to substitute everything that we know from the diagram. So in this case, we're looking for AD, which we labeled B. So you plug in those side lengths, and the angle that we're looking at over here is this 75 degrees because that's opposite B. So now we know that A equals B, so we're going to substitute. So try to rewrite that equation and solve for B. So when you substitute, this is what we get. Now you subtract B squared from both sides, and those cancel out. That'll be this step. All right, so we simplified over here. 2 times 132, 264. We evaluated the square right here. And now we just got to solve for B. So the way I solved it was I added this amount to both sides. And to get B by itself, we just got to divide both sides by 264 and cosine of 75. And at this point, you can just plug it all in the calculator. Let's see, 17,424 divided by, and make sure you use parentheses, or else it won't think that you're putting that cosine in the denominator. And there we go. So about 255 meters. It's not always going to work out that way. Those squares cancel out. We have an example with a parallelogram. You want to figure out the length of a C to the nearest millimeter. So this is 100 degrees, and since it's a parallelogram, we know that these have to be supplementary angles because they're same side interior angles. So if that's 100, that has to be 80. And we're looking for this length, let's call that D. It's across from vertex D. So why don't you use the law of cosines using this angle 80 and write an equation. So here's my equation. And now you notice the variable is only on the left-hand side. So all we have to do is evaluate the right-hand side. So at this point, you could plug everything into the calculator. I like to simplify it step by step to show all my work. And we're going to get a number over here that's not a terminating decimal or anything. So make sure you don't end it too soon in your calculator. Don't round until the very end. So this is equal to D squared. So how do we get D? We got to take the square root of both sides. So to the nearest millimeter, about 47 millimeters. And finally, we can also use the law of cosines to figure out an angle measurement when all we know are side lengths in a triangle. So in this example, we want to find the measure of angle A. Let's mark that angle. And this is the form of the equation we want to use. So make sure that A, this 25, is over here. And it doesn't matter what order you put B and C in. One's 14, one's 23, but B really should be the 23 because that's across from angle B. So we substitute, and we get this amount. Now, we want to solve for A. So we got to move all these numbers to the other side of the equation. So I like to simplify it step by step. And at this point, we want to subtract that 725 from both sides. I want to divide by that negative 644. And you simplify your fraction, and that's what you get. So negative 100 divided by negative 644. Oops. Sorry about that. Gives us this number. Math, convert to fraction. There we go. So now we got to figure out what A is. So to cancel that cosine, we have to use inverse cosine or arc cosine. So second cosine, I'm going to input the previous answer, so second answer, and the negative sign. And that's where we get that number from. So round to the nearest tenth is about 81.1 degrees. So I always thought this was really cool. You're able to figure out an angle measurement when you know absolutely nothing about the angles, but only the side lengths. So that's one other application of the law of cosines. In this lesson, we learned how to derive and apply the law of cosines. Thank you for watching this video.